Probability and theoretical distribution. The value of a probability can vary from 0 to 1. The higher the probability of an event occurring, the more confident we are that it will come about. So probability of an event happening is the number of ways it can happen divided by the total number of outcomes. Let's say if the probability of raining is 0.9, which means there are higher chances of it raining. If the probability is 0.1, which means there are less chances for it occurring. So probability is just a measure of likeliness of an event occurring. So the chances of rolling a die with a die is equal to the number of ways it can happen, which means 1, because a die has got 6 sides, 1 up to 6. There is only one face with a 4 on it. The number of outcomes, there are 6 faces altogether. So the probability of getting a 4 when you roll a die is 1/6. So remember, probability, number of ways it can happen, divided by the total number of outcomes. Probability line. So as we have discussed before, probability, it ranges from 0 to 1. So 0, it means it's impossible. 1, it means it's certain, it's definitely gonna happen. So now, as we move to 0.5 here, it means there's an even chance of that it can occur or it can't. So the common example is the coin, a head or a tail. So there's a probability, 50% probability, 0.5 probability that a head or a tail is gonna come. So you see, as we move from 0 to impossible, from 0 is impossible. As we move away from 0, it becomes unlikely. As you go to 0.5, it becomes even chance. As you move away from 0.5, you could get a likely event. Then to 1 is certain. So probability is always between 0 and 1. More probability theory. Independent events don't affect the probability of each other occurring. So it means if I throw a dice and get a 4, it does not affect the probability of getting another 4. It means as long as I'm using a fair die, it means whenever I throw the die, it is always going to be a probability of 1/6. In this case, when you're saying getting a 4. So independent events don't affect the probability of each other. So it means whatever happens on one situation does not affect the other situation. So probability law of conjunctions states that the probability of 2 independent events are jointly occurring is a product of their independent probabilities. So if we're saying, looking at the same probability of a die, it means, let's say, probability of getting maybe a 4 and a 2 is equals to probability of getting a 4 multiplied by probability of getting a 2. So we are saying probability of getting a 2 and then a 4. It means the probability of getting a 4, it's 1/6 times probability of getting a 2 is also 1/6. So the final answer will be 1/36. So here it's the case that you're saying you're rolling a dice, then you get a 4, then you roll a dice again, then you get a 2. So that's how we are doing it. The probability law of disjunction states that the probability of either of two independent events occurring is the sum of their probabilities. The probability of disjunction states that the probability of either of the two happening. So now we are saying probability of getting a 4 or a 2. So it's either or. So now instead of multiplying, we now add, because we are saying if you get a 4, it's okay. If you get a 2, it's also okay. So we add. So if you add them, you get 2 over 3. It's 2 over 6, which is equals to 1 over 3. But if you leave it as 2 over 6, it's okay, unless you are required to round off. So this is the difference. So we are saying A and B, which means these are joined, they should occur together. Then either or, this is A or B, it means they can occur separately. So we just add them. So let's give an example. Probability of multiple outcomes. So this is a probability of a coin. Remember we said to get a head or a tail, it's 50%. So now, so if they ask you, so this is like a probability tree. Let's say we are throwing the coins twice. So if we throw the coin on the first instant, there's a probability of getting a head or a tail, which is 50-50. If you get a head on the first throw, it means on the second throw, there's still 50% chance of getting a head or a tail, which is the same on the tail first. Then, so if they ask you the probability of getting 2 heads, means probability of getting 2 heads is H is equals to probability H and H. So it means 0.5 times 0.5. So it gets it becomes 0.25. That's the thing. So which is the same, if you probability of getting a tail and a head, it's just the same. You say probability TH (0.5) So you get, so it's probability T times probability head. So you get still the same since the values are the same. So this is basically what you should do. So now the situation, so if you are going along the branches, it means you are multiplying. If you are going across the branches, it means you are adding. So some of these things will become clear as we do more examples. So let's move on. This is a practice question for you. You are off to soccer and love being the goalkeeper. Love being the goalkeeper, but it depends on who is the coach. So with the coach Sam, the probability of being a goalkeeper is 0.5. With Coach Alex, the probability of being a goalkeeper is 0.3. Sam is coach more often, about 6 out of 10 games. It's the probability of Sam being the coach. So what is the probability that you will be a goalkeeper today? So may you try to solve this one, and we will look at it in 5, 4, 3, 2, 1, pause. I think you've managed to do something for that question. So we can look at the solution to practice question number 9. So what you do, first you draw your probability tree. So you can see that this Sam being the coach, Alex being the coach. So remember, probability of Sam being the coach is 0.6, which ultimately means probability of Alex being the coach is 0.4. And if you notice these values, they should always add up to 1. So probability that Sam will make you the goalkeeper is 0.5, and probability that Sam will not allow you to choose another person is also 0.5. If probability of Alex choosing you is 0.3, probability of Alex not choosing you is 0.7. So you can see with the coach, the probability of being a goalkeeper is 0.5 with Alex, but between the two, Sam has more chances of being a coach because it's 6 out of 10. So Sam being a coach, 0. Alex being a coach, 0.5. Probability of him choosing you, 0.5. Probability of Alex choosing you, 0.3. So now the question is saying, what is the probability that you will be a goalkeeper today? So there are 2 scenarios that can happen. One, if Sam is the coach, you can choose you to be the goalkeeper. Or if you find that Alex is the coach, you find you to be a goalkeeper. So what you do now, you will select a probability of you being a goalkeeper is equals to probability of Sam being the coach and he says yes, you're gonna be a goalkeeper, plus probability of Alex being the coach, and you say yes. So basically what we are saying here is like we are multiplying this probability and this probability, this probability and this probability. So it's 0.6 times 0.5 plus 0.4 times 0.3. So this is how it goes. So if Sam says yes, if Sam is the coach and he says yes, it's 0.6 times 0.5. If Sam is the coach and says no, it's 0.6 times 0.5. If Alex is the coach and he says yes, but now the figures that we need is for you, probability of you being the goalkeeper. So which means it's this one and this one. So we add these two and we get 4.02. So therefore the probability of being the goalkeeper today is 0.3 plus 0.12. So your final answer is 0.42. Let's move on. Practice questions for probability theory shall be covered in the exam. So more questions on this shall be covered in the exam section, which is section 7. Normal distribution. 7 features of normal distributions. Number 1, normal distributions are symmetric around the mean. So you can say usually a symbol for normal distribution like that, which means the middle part is your mean. So they are symmetric, which means the mean, middle point, divides them into 2 equal parts. The mean, median, mode of a normal distribution are equal. So mean, median, and mode, we discussed them in the previous chapters. Of a normal distribution, they are equal. So if it's a standard, a normal distribution where it's standardized, your mean is 0 and your mode is 0. and your median is 0, and your mode is 0. The area under the normal curve is 1, is equal to 1. So in this case, it refers to a standardized where 0 is the middle point, and it stretches from minus to plus whatever. Anyway, normal distributions are denser in the center and less dense in the tails, which means in the center, that's where there are more data here, and at the tails there are less values or scores there. That's what we mean. Normal distribution are defined by two parameters, mean and standard deviation. 68% of the area of a normal distribution is within one standard deviation of the mean. So what it basically means is, this is your so let's say this is symbol for standard deviation. Let's say one standard deviation is this one. This is another one standard deviation. So what it basically means, this is your middle part, your mean. So it means the distance from here to here. So when you talk about standard deviation, we're talking about the negative part and the positive part. So this whole area, we are saying is approximately equal to 68%. Approximately 95% of the area of a normal distribution is within two standard deviations. So it means if we add another standard deviation here and another one here, it means that if there are two standard deviations now, it means this area is approximately 95%. So those are the 7 properties you should know about the normal distribution. So let's move on. Normal distributions differ in mean and standard deviation. So these are different types of normal distributions depending on the type of data. You can see some of the data can be densely more dense. This is more dense data, is mainly on the same values, and this one is also a bit less dense, and this one is with a bigger spread. So it depends with the data you are given. So I just wanted to illustrate that the normal distribution can be in different shapes and forms. So this is the formula of the normal distribution. So they say if X is a normal distribution with mean nu and standard deviation, this one, we write that X follows a normal distribution. X follows a normal distribution of, this is your mean and your variance. So standard deviation squared is equal to variance. So just know that these are the two things you need to know. So let's move on. Standard normal distribution. A normal distribution with a mean 0 and a standard deviation of 1 is called a standard normal distribution. A value of any normal distribution can be transformed into its corresponding value on a standard normal distribution using the following formula. Z is equal to X minus mu, which is your mean, over your standard deviation, where Z is the value of the normal distribution, X is the value of the original distribution, mu is the mean of the original distribution, and this sigma is the standard deviation of the original distribution. So to illustrate this, we will work out the following example 1. What proportion of a normal distribution, when you say what portion of a normal distribution with a mean of 5 and standard deviation is below 26? So now this is your data. So your X is equals to 26. Your mean new, or we can use this, is equals to 50. Let's use this mu is equals to 50, and your standard deviation is equals to 10. So for you to solve this one, we say we want to find this z value. So we want to we know that z, which is the value of the normal distribution, you're converting x minus mu over sigma. So we know that the value of z is 26 minus mu, which is 50, divided by 26. Then we get our z value. So let's look on the next page. So when you do that, you get minus 2.4. That's your z value. So, but now the thing is, we want to find what portion of the normal distribution with a mean 50 and standard deviation 10 is below. So when you're saying below, we mean, remember, your normal distribution is like this, where your 0 is here. So minus 2.4 is here. So we want below, which means is this area. So it means it's this area that we are looking for, this below, not above, but below. So let's move on. So now when we go, so you can see that from your data here, this is the normal distribution tables. So you can find them in your normal textbook or any other place where you can find them. So now we are having, so remember we got our value is 2.4, minus 2.4. So you can see that the z value that you get here, it will be indicated here. So that the value you get, it represents this area. So now when you're talking about minus 2.4, 0, so minus 2.4, let's say it's here, minus 2.4, which means you are talking about this area. That's what we want to cover. So now what you do, you go to minus 2.4. Since it's minus 2.4 and there's no decimal, which means you go to there's no extra decimal after the 4, so there's a 0. So it's like minus 2.40. So here there is no 0. If there was a 1, you would go to this column. If there was a 2, you go to this column, because it becomes minus 4.42. But since it's minus 4.0, first you go to locate your minus 2.4, then you come to this 0 column. So this is your portion, which is equivalent. So this is the area or the probability that is on this. So this area is represented by 0.082. So this is your portion. Hence, from the tables, we can see that 0.0082 of the distribution is below minus 2.8, indicated by the shaded blue area above. So you can see minus 4.022. So now, example number 2. X is normally distributed variable with mean 30 and standard deviation 4. Find the probability that x is less than 40, probability that x is greater than 21, and probability that x is between 30 and 35. So what you do here is the same thing. What you do, so probability of x less than 40 is equals to so you convert the x into z, so it becomes x, z is less than, so it becomes 40 minus your standard, your mu divided by your standard deviation, which is 4. So for the second one, x is greater than 21 is equals to p, we convert our x into z. So it becomes 21 minus mean over 4. So you calculate this one. And for part C is 30 set x minus 35 less than 35 I mean. So for you to do that, it means you convert your x into z. So first do the 30 minus 30 over 4, then your x becomes a z, so you have to be 35 minus 30 divided by 4, like this. So I was just giving you an idea of how you calculate it. So let's deal with them individually. So for part A, what is meant here by the area is the area under the standard deviation curve. So for part A, x is equals to 40, calculate the z value, you get 2.5. So what it means, probability of x less than 40 is equal to probability of z less than 2.5, which is the area to the left of 2.5, because you want greater. So according to this graph, you see that if you enter 2.5, it gives you the area here, but what we need is this area. So from these tables, it will give us this shaded area, which means if you want to find this one, we have to subtract that area. So we want the area that is, remember, here we want the area that is less than. So the graph gives you the area of the z value up to here. That's what the value gives. If the sign was greater than 2.5, it means you have to find this one by subtracting 1 from the value you get here. So the table gives you values less than. Again, because this is the key to this table. So now, because we found our z value is 2.5, so it means we go to 2.5 here, divided by the arrow. Then since there's no other value here, so we go to 0. So it becomes 0.9938. So this is your probability of x being less than 40. So let's move on to B. So for B, x is equals to 21. So converting x into z, it's 21 minus 30 divided by 4, we get minus 2.25. So now we want the area that is greater. Remember, I mentioned it before, greater. So we want the area that is greater. On the area that is greater. So it's total area minus area on the left, minus 2.25. So we want something that is greater. So this table, it gives you area which is z or less than. But if you want greater, it means this unshaded area. So it means the table will give you this area. So to find this one, you have to subtract this one from 1. So area under 2.2. So let's draw it like 0. So minus, let's say it's here, minus 2.25. Forgive my handwriting here. This pen is it. So we want to calculate this area. So it means that the value you get from the table, it will be this one, but you want this one. So it means the one you get from the table is subtract from 1. So 1 minus x, which is the value you get from the tables. So now from the tables, you go to minus 2.2. Minus 2.2 is here, but you need 0.25. So you go to 5. Then you go and you link them like this. So this one will be 0.122. So it means it's 1 minus 0.122, and you get 0.9878. So always the key to solving these equations, this normal solution, should look at the table, like which area does it gives you. So the shaded region is always represented by the values that you are getting from this table. So first you must analyze, or sometimes the tables will come in different dimensions, so you must check if which area is being represented. Otherwise you get used to this type of table, and maybe you are given a different type of table. So but what you should know, you should check your table, then you check which area you want. So the table is giving you the one on the left, but you want the one on the right. So it means you just have to subtract. So 1 minus 0.0122, that's how we get it. So for C now, we want the area between. So you first find for x, then 30 minus 30 over 4 is 0. Then for 35, is 35 minus 30 divided by is 1.25. So now you want the area which is between. So when you convert it to z, it becomes the area between 0 and 1.25. So it means area on the left side of z minus area on the left of 0. So what we are basically saying is this. This is your 0, and this is your 1.25. 1.25. So basically what we are saying, this graph is giving you area on the left. So 1.25, it gives you all this area. Yeah? Then 0 is this area from this type. So it means if you find the area of under 1.25 and subtract from 0, you are left with this one. That is between 0 and... So that's what this graph means. So always check this, what it means. So now, to find the area under 0, you say 0 is 0.5. Then the area under this 1.25, so you go to 1.2 and 5, you get this 0.844. So we are saying the area, the proportion under this is 0.8944 minus 0.05, and you get this one. So this is your area proportion between 30 and between 30 and 35 is 0.944. So practice question on normal distribution are the following. So there's practice question 10, 11, and 12. So you can attempt these ones, and you can pause the video in 5, 4, 3, 2, 1, pause. I guess you have managed to solve them, and you checked up with your tables and stuff like that. So the next page will show you the solutions to question number 10, 11, and 12. So if you solve them well, we are supposed to get these values. So it's just the same procedure. Your x, you determine your z by subtracting the mean over the standard deviation, then you get something like this. Then for b, it's between. So you just do like what you did in the previous example. Then you get these ones. And for 11a, x is equals to 8a. So you just do the same thing. But remember, you must read your questions carefully. And I think if you're able to follow through, you will be able to work this one out. But if you face any challenges in working this one out, you can contact me. My numbers are here below. Then I can help you to work it out. But as far as I'm concerned, I think I will demonstrate how to do it. And if you follow the instruction, you'll be able to solve them well. But however, if you find it difficult for you, you can always contact me. I'm here for you, always there, available to help you at the shortest time available. Linear interpolation. Linear interpolation is used to predict the scores that are not recorded in the Z tables of the standard normal distribution. Suppose that you are asked to determine the Z score above which 20% of a normal distributed population falls. You note that a proportion of 0.2 is not recorded in the Z tables. The closest proportion are 0.005 and 0.1997, which means 0.2 lies somewhere between these two, 0.2005 and 0.1997. This means that the true Z score lies somewhere between 0.8 and 0.585. So we see. So remember, we are moving. The proportions are these ones on the highlighted here, and these are the Z scores. So we want to move from the proportion. So these are the proportions. So the proportion is 0.2. But if you look at this number, so this is 0.1, 0.17, so 0.2, 0.005 this one, and 0.1977. So that's why we're saying it's correspond to 0.84. See this one, 4, and the other one is 0.85, which means 0.2 somewhere here. So this is what. So remember, this is a negative. It corresponds to this area here. So now, therefore, we can use linear interpolation to determine the exact Z score as demonstrated in the next slide. So here are the Z scores and here are the proportions. So 0.85 correspond to 0.977, 0.84 correspond to 0.2005. So 0.02, we want to determine the Z score. That's what we don't know. So use the equation of a straight line, y is equal to mx plus c, which can substitute Z scores and proportions. We can substitute Z scores and proportion we have into this equation to obtain the following two equations. So this one will be your y, and this one will be your x. So 8.5 your y and 0.1977 your x. Remember your x here. And you are left with m and c. So this is the same thing on the second equation. You substitute 0.84 into 0.22, then you get these two equations. Once you get those two equations, we want to solve for m and c, so we therefore subtract equation 1 minus equation 2. So equation 1 minus equation 2 means C minus C gets 0. So we eliminate the C here. Then from there we are left with 0.85 minus 0.84, you get 0.01. And you separate this one from this one, you get minus 0.0028 M. So we solve for M and we get M is equals to minus 3.5714. So we substitute M into equation 1, this equation 1. So we put our M, since we now know the value of M. So when you do that, we get, this is the M. Remember, this is the M. We substitute here. So, and the 0.1977 plus C. So once we do that, we simplify this expression and we subtract it from there. So you're supposed to get your C. So once you get your C and your M, it means you have your final equation of the straight line, like that. But we want to determine for 0.2, which is your X. So you substitute here 0.2 for X. Hence, when X equals 0.2, we put your 0.2 here. So you simplify this one and you get 0.84182. So therefore Z value which corresponds to a proportion of 0.2 is 0.418. So you can see it's somewhere between 0.5 and 0. So our question mark here is 0.418. So you can see it's between these two. So that's how we do linear interpolation. So you can revisit this and make sure you know how to determine. So here, our previous normal distribution, we were working from Z and finding the proportion, but this time we came from the proportion to the Z value. So I think it's well done here. So let's move on. Things to note: the normal distribution can be used to approximate the binomial distribution. However, we will not cover this as it is beyond the scope of this course. But if you perhaps need to know about it, you can contact me. Then I can be able to explain it to you. But if you think you don't need to know it, because it's not covered in the IOP 2601 module, so for me, I will not do it as well. But if you need to know about it, you can contact me. My numbers are here below. So let's move on. Thank you for watching. If you have any questions concerning this section or you need any further information, call us on 074-920-9697. Thank you and have a great day.